So, good afternoon, ladies and gentlemen. My name is Chang. I work for Heraeus. Today, it's my pleasure to stay here to talk about the precious metal catalyst, the key to hydrogen transport via ammonia. So, I want to take the short time to introduce my company. Actually, Heraeus is a German family name. We are a family-owned company. We generate in average 30 billion euros per day reference. We have around 60,000 employees and working in more than 100 sites in 40 different countries. We are the top 10 family-owned company in Germany. We have so far I make a mistake. So here is 11 business units so far. We had 12 in last years. So Heraeus has 11 business units separated in 3 different topics. The first one is precious metal. We are one of the biggest precious metal fabricator of the world. We supply the metal in different ways, including the silver, gold, palladium, every precious metal you can think about. We also use the precious metal as our raw material to produce different material, for example, catalyst. The second part is advanced material. So we produce the polymer, produce the glass, to support the different industry, for example, semiconductor industry, electronics, and renewable energy. We have our own technologies. We produce special sensor which used in metallurgy industry. We have our own lighting solution, and we can produce our own medical devices. So why Heraeus can create so many possibilities? Because we have controlled all precious value chain. And here I want to take an example how Heraeus can supply to support hydrogen economy. So we do the precious metal trading, raw material for catalysts. So including the platinum, palladium, rhodium, ruthenium, iridium, gold, and silver. So many catalyst producer is our customer. We also do the pen electrolyzer catalyst. Is iridium and platinum catalyst, which you can coating on your membrane. We also provide the catalyst for hydrogen and oxygen purification downstream of electrolyzer. Of course, so far, LOHC is a quite hot topic. We have a catalyst for hydrogenation and dehydrogenation. If you're using the ammonia as a hydrogen carrier, we have a catalyst ruthenium basis for do the ammonia cracking. And of course, we support some application in this economy. For example, sensitive fuel and have our customer to reach their target of decarbonization using the methanation catalyst. And we support also catalyst for fuel cell. And finally, we collect the spent catalyst back to do the precious metal recycling. This is so kind of a loop business what Heraeus can provide. So let me talk about hydrogen storage. So there are different methods to do this hydrogen storage. You can use the high pressure, you can use the low temperature, you can store that on the surface phase, for example, magnesium hydride, and all of them you will need high energy consumption. And of course, you can choose the liquid phase, for example, LOHC, but you have to face the problem of the byproduct, and the reaction is not easy to control. Of course, you can use the methane or the methanol, but if you release the hydrogen from both of them, you are far away from the target of decarbonization. And right now, I think ammonia is the best choice so far we have. So it's a carbon-free and easy transport and easy to store. So I believe ammonia is an ideal hydrogen carrier because they have a high energy density, higher than liquid hydrogen and higher than LOHC. This is very convenient and is an existing product of the market, easy to produce. You can trade in and you can use the existing infrastructure to transport and storage. Therefore, that will be cheaper. So this is the good pathway how ammonia as ideal hydrogen carrier. You produce with green energy somewhere of the world and transfer it to your local place. And you use the Heraeus ruthenium catalyst to do the cracking and release the hydrogen. So in every gas station, for example. Let me talk about some catalysts. So this is somehow catalyst look like. We have a coating technology. We can coat the active material and every catalyst supporter. It could be alumina or the zeolite, even a honeycomb or a meta honeycomb. And this catalyst so far is ruthenium basis. We can coating. We can change the standard loading. So far, standard loading is 2.0% of ruthenium. We can go down to 0.1%. It depends on the customer request. So the standard size of this catalyst is 2 millimeter. But if you think about you have a bigger reactor, you will need the bigger catalyst. We also can change the carrier depending on your request. The bulk density is around 500 kilo per cubic meter. The crash strength is bigger than 18 newtons. The BET is 200 square meter per gram. So we believe precious metal catalyst is an efficient and durable solution for hydrogen generation of ammonia cracking. So we can support you with a different carrier size, different form, in order to fit your big or the small reactor tube. So we can do the additional precious metal loading for you, and even the non-precious metal doping is possible. We provide a faster and flexible prototyping with a customized solution for you. So some kind of catalyst data you will see in the figure A, two curves. The dark one is Heraeus ruthenium catalyst performance curve. The reaction temperature is from 400 degrees C to 550 degrees C. In your right side, with the light green curve, is a non-ruthenium catalyst. You can see, obviously, you will need more temperature. So in order to reach 100% conversion, you will need around 800 degrees C. So that means the energy consumption is a huge difference. Two factor is very important for the performance. The first one is how to coat it, the active material on the suitable carrier. You can see this is a half sphere. The black shell one is active material is well distributed on the carrier. The second factor is metal narrow particle size. We have a technology to control the particle size in a limitation number. So what did we do and what we'll do in the future? We will do investigation for many different metal precursors, for example, ruthenium chloride, ruthenium nitride, ruthenium sulfate, and we do the different loading tests. And we also interested in influence of any promoter and what is the ratio can bring us. And also the support material is also important, is that stable enough. And we also do the investigation of the feedstock and operation condition, depending on customer requests. And synthesis impact is also important for the performance. And basically, physical and chemical characterization is our daily work. So what benefit do you have if you're using the ruthenium catalyst? You will have the excellent performance at a low temperature, relative low temperature. So you will saving energy for your cracking process. So actually, the mechanic and thermal stability is very depend on the operation temperature what you have. And Heraeus provides a metal recycling service. If you use the recycled ruthenium in your catalyst, you will dramatically reduce your CO2 footprint. Such metal called gray metal or secondary metal. This belongs to our loop business. So Heraeus is a very a serious company to do the decarbonization. So we set up our project in the beginning of the 2019, and in 2025 we will reach carbon-free, carbon nature. We will use 100% green electricity, and we will avoid losses and increase our efficiency. And we wish this is a challenge of us. We will get net zero greenhouse gases emission free in 2031. So we will complete turn away from the fossil fuels. So the short summary, the precious metal which can be used through all the hydrogen economy value chain. So we have a state-of-the-art cracking catalyst available for you, or even a tailor-made solution. You will get excellent activities and low temperature using Heraeus ruthenium catalyst. We provide a recycling service. You can dramatically lower your CO2 footprint. And finally, we are looking for a partnership, especially engineer companies, to help us to set up a process. And of course, we will modify our catalyst to fit the customer request. Thank you. Any question? Yes, please.
How do you reach 100% conversion when the reaction is in equilibrium? What are the reaction conditions you've used?
We also right now we just do the laboratory test in 1 bar and 5 bar, and then other side we will give over to our partner to do that.
I still don't understand how you reach 100% conversion.
Maybe we can talk later.
Okay, thank you very much.